All right, welcome everyone. My name is Emily Andrews. I'm the Executive Director of the Missouri Gateway Green Building Council. We're here for our third Friday coffee break. These are opportunities for our green building community to connect on different hot topics related to sustainability with some short presentations and a little bit of discussion. So today, our hot topic is regenerative design, and we are hearing from Colin Rohlfing, who is the Vice President and Director of Sustainable Development at HDR. He's an industry expert in sustainable and regenerative design and is the head of HDR's Director of Sustainable Development for HDR's global architecture practice. So in the past 20 years, he's held various design and leadership roles and was actively involved with President Obama's Export Council Sustainability Committee, with USGBC, with AIA, Committee on the Environment, the Biomimicry Guild, and the International Living Future Institute, all kinds of good stuff. So I'm going to turn it over to Colin, and he's going to give us a little presentation.
Yeah, hey everybody. Emily, thank you for having me. Thank you guys for tuning in. I want to make sure you guys can see my screen and hear me okay. Everything looking good?
Yep, looks great.
Okay. Yeah, so I think this whole topic started years ago. I used to work for HOK, grew up in St. Louis and worked for HOK at a global scale in sustainability as well, which maybe you guys know them more than HDR, but I've been at HDR for 8 years now. We worked quite a bit with the Biomimicry Guild to try to understand how we can emulate nature and attach nature's principles and design metrics to our projects. And it was always a very tough process because we didn't have the data. And so for the past 5 years, I've been working on this regenerative framework with an associated tool to quickly get data, quickly do calculations to set regenerative targets on projects. And the reason I would like to set regenerative targets in lieu of sustainability is a number of reasons. I think the word sustainable is as lovely as it is, has run the course a little bit and has become greenwashed. And I do fear that regenerative design is also, the new buzzword and may at some point get greenwashed. But the intention is in lieu of, we're not really hitting sustainable targets when we have sustainable projects. To truly be sustainable, we really have to, emulate nature in those cyclical processes and hit net positive targets for ecology, health, and community. Even our most high performance projects, maybe if they're saving 85% of their energy use intensity, are still having some negative impact on the environment, on ecological systems, and on social systems. So the intention here is to truly look at this from a holistic point of view and get net positive targets in all of these categories, which is a difficult thing to do, but I'll show you some projects that have been achieving net positive targets in various categories. The whole idea is, though, have a project that does it for everything. And so you start a project by looking at kind of broader interconnected systems. It's not just about your singular project on a site. You have to consider how that project impacts broader social systems, or how that project impacts broader ecological systems at these scales, and vice versa, how those things are impacting your project. And I think I heard it best from Bill Reed, the founder of Regenerative, who kind of has inspired me to create this framework, and they've been doing regenerative design for 30 years, is that whenever he starts a project, he says, your project is the system. It's not the project itself. Every time we do design work, you are working on the system. It's not about just your project boundary. And we have to understand that these things are connected, right? The built environment can produce greenhouse gas emissions, which impact air quality, which also impact natural disasters and temperature precipitation increases in the future. And then, the social systems are also in this loop. Those elements, whether it's air quality or climate change, can produce poor mental and physical health, as well as cause future pandemics with the permafrost melting. So once we notice the system is what we're designing to, and we gather data from this system, that's when we can truly consider design solutions that are regenerative. And so this framework tries to look at all of these systems together, right? Not just carbon, not just air, not just water, but how they're interrelated with biodiversity, nutrients, and social systems like human health and community. And the intention is everything we've been doing for the past 30 years is kind of under this massive umbrella. This includes resiliency planning. It includes a focus on net zero emissions. It includes a focus on human health. It includes a focus on decarbonization and electrification. And so we're trying to use this framework as a way to start our projects. And I think the most important thing is kind of this idea of a tool and a calculator, which allows us to get this information as quickly as possible. So this tool has about 125 data sets and 40 different individual calculators. So you can drop a pin for a project and set an ecological baseline, that white pin right there, and try to pull in metrics from that site. So what's the carbon cycle, the water cycle, the biodiversity, the acoustics from that ecological baseline that we want to emulate for our site? We can also quickly see what future temperature and precipitation data is going to be for the site, what kind of natural disasters for FEMA flooding maps we might have to deal with, although these maps are already out of date, right, constantly being updated. And it graphs out the entire carbon life cycle of the project. So we can see operational carbon, embodied carbon, the renewables to offset it. We can do very quick water calculations to figure out how we get to net positive water with just some few inputs. But that broader systems thinking is bringing in air quality data from nearby air quality monitoring stations and getting down to that census level to figure out which communities are socially vulnerable to quality risks or disaster risks, etc. You can always see that these communities typically are disadvantaged communities. And our project site there with the blue pin is actually plugged into that utility plant, that green little dot right there we just clicked on. And those emissions are blowing right into that disadvantaged community, right? So it's not just about our project site, you're designing for the system. And then once we know this information and look at all of the data, that was just a small sample set, we then make correlations. What are having the biggest impacts on the community, on the ecology that we can focus on in our project? And here you'll see that goes back to my comment about emissions impacting air quality, impacting human health, impacting social equity, and where do we have the biggest opportunity on our project to develop within that system. And the framework itself allows us to then track these metrics. Can you achieve net positive targets for all of these categories, or regenerative categories, targets for all these categories? And as you get to the outer ring of this framework, you're hitting more regenerative targets, and you cannot fill out a circle unless you have a resiliency plan for energy or for water or for human health. And so that's kind of how the framework is put together. And I just wanted to show a couple of projects where, it's great to have a framework and all these, lofty ideas, but where does the rubber hit the road? And so, first and foremost, there's a focus on operational carbon, turning off the tap, addressing the biggest gorilla, in the room. And, this is the Orange County Sanitation District headquarters, which is net positive carbon. We are able to take an office building, implement appropriate layout of the spaces. The entire building layout was designed for maximized daylight and reduced glare. But then the envelope allows only 2 watts per square foot coming through the facade. That allows for a acid chill beam solution with daylight controls. And just through this kind of very simple solution with off-the-shelf technology, the building itself has a 72% energy use intensity reduction. Now we drive the remaining offset through renewables on the roof and the nearby parking garage, but then we were able to capture biogas from a nearby wastewater treatment plant to drive an electric boiler on site. And so this project with the solar array is actually giving electrons back into the grid, removing carbon from the system that is serving this district. And so, that is a net positive carbon approach for a building, which is kind of our first and foremost target, but we also have to consider the embodied carbon impacts of these buildings. The future of construction, yes, does have some increase in operational carbon year after year as the building stock grows, but we're going to see a big portion of this be focused on embodied carbon. It's almost half of the equation here when we think about future of carbon in our projects. And so the embodied carbon of these projects, we try to look at alternative solutions. Right now we have a lot of mass timber projects, but mostly Pacific Northwest, Northeast, a little bit of interest in Minneapolis right now in the Southeast, where we have availability. But if we can't do mass timber, we look at low embodied carbon solutions for concrete. such as you can only go so far with fly ash. You have to look at recycled cementitious materials, an aggregate to get that down, and then trying to offset the rest with other rapidly renewable materials. Steel, we can look at places where arc furnaces are used for production. Sometimes it requires more shipping, but the intention here is that a cubic meter of wood can sequester about a ton of carbon, and it takes about to produce a cubic meter of cement also takes about a ton of carbon. So can we use these buildings as carbon banks? Can we specify rapidly renewable materials and mass timber to get that embodied carbon story down? And this is a kind of a behavioral health inpatient facility in Seattle. And the whole thing was built a kind of a hybrid structure of concrete and mass timber for the upper floors. And so when you look at the entire embodied carbon impacts of these materials, yes, you have concrete and metals and woods and plastics that are emitting carbon, but with the specification of wood materials, wood structure, mass timber, with the reduction in the footing size because the building is now lighter, you can actually get a carbon balanced building that sequesters more carbon over this life cycle, 23.5 kilograms per square foot, cubic foot, as opposed to 21.5. So in our minds, we're banking this carbon and sequestering more than we're emitting for a net positive embodied carbon balance for this building. Now, at some point, this is going to be disassembled. So design for disassembly is really important. Can we design joists without screws, without glues, to allow for disassembly in the future so that these beams and this beautiful interior space is not just landfilled in 75 to 80 years. But even if it is, we are at least banking some of that carbon that would be emit at a really critical time where we're about to go over a threshold of 1.5 degrees Celsius for the planet. And it's just a really great biophilic design engagement here. We have less finishes, which also reduces the embodied carbon. It makes the space more beautiful for people to be in. And I think that it has a lot of great potential for applications beyond just, office buildings. We're doing it now, looking at labs, looking at healthcare facilities, data centers are considering it. And so those are the two biggest things to start with, operational embodied carbon. But again, you cannot design in those silos, right? What are these broader impacts that are happening? And so this is the Lawrence Berkeley National Lab Welcome Center, where the big focus was looking at that nearby community. They serve the broader population with science and research, but there is a focus on how this is going to impact the nearby Berkeley community. And if we look at the air quality in the region, it's okay. That's harmful for about 21% of the year. But if we zoom in a little closer using that regenerative tool data, we can see that within this neighborhood, those dark purple spaces have a very high percentage of PM 2.5, about 96 to even 100th percentile in the nation. And PM 2.5 is not, just asthma causing or, it's really nasty, small stuff. And these neighborhoods, when we overlay this with our kind of equity overlay, these are disadvantaged neighborhoods. And that green little dot right there is our central utility plant. And the windrows that's pulled in automatically is showing that, we're kind of, blowing a lot of this particulate matter into these disadvantaged communities. And so this is not just about the Berkeley campus, this is about the nearby community. And asthma rates are, of course, very high, right? Again, going back to that statement of your project is the system, not the project itself. And asthma rates are 3 times higher for children in this area. And so it was really important for us to focus on what this means. I mean, there are mortality issues here. PM 2.5 doesn't just get into your lungs, it gets into your bloodstream. It causes heart disease, it can cause strokes and aneurysms. So to some extent, our project is contributing to mortality beyond asthma. And this is not just, local to Berkeley, this is a global issue. PM 2.5 is kind of attributed to about 7 million deaths globally, 1,500 in California, and a very large chunk of healthcare costs. And so the more we're able to make these connections at broader system scales, the more justifiable these solutions become in our projects. And so this is an all-electric building. the focus was no combustion on site, targeting net zero, but backup generation power is fuel cells. We're not looking at natural gas or diesel on site for backup generation. Even the kitchen went all electric. And so they were able to provide low carbon foods that were, more raw foods when what cooking was done with induction stoves, was done without combustion. And so it's very hard to tell a chef, we're taking away your natural gas and your flame, but it was really important to the client and was implemented. And this idea of designing for electrification, decarbonization, because it's not only the right thing to do for climate change and for operations, but for the health of those individuals in the nearby community is a major focus of the regenerative framework. Equity, not just ecological systems, but social systems, right? How do we focus on social justice? How do we identify social inequalities in the community, and how can our design projects respond to them? And sometimes it's really tough because people think, well, I don't have control outside of my project boundary, but I would beg to differ. And this is an example of how we beg to differ. This is the University of California, San Francisco new hospital, Parnassus Heights. Their mission statement is focus on equity. And so we pushed them really hard to have a social equity engagement, which was not in the original RFP. And I want to reiterate that Orange County building, they didn't want net zero or net positive carbon. We had to push them and show them the calculations, and they said, okay, this is something we can do. And so don't think that this is all just happening in California because this is part of the requirements. Each one of these projects did not have these things until it was pushed and until it was justified. With this project, again, we looked at the community. It's a hospital. Their intention is to serve the community. The Hippocratic Oath, do no harm. And so these are some of the communities they serve. In red, they're disadvantaged communities. In San Francisco, there was a lot of concern about social vulnerability, not only disaster planning and the ability to respond from a disaster, where to go. Do they have the fiscal means to get someplace safe? They don't. But there was a big focus on heat stress. And the heat stress was a big concern in this microclimate in San Francisco, whereas where we're located is up a little higher and they don't have that same heat stress. And so the design solution became this idea of park to peak, connecting the building to the local park, making it public, giving people access to this project so that this entire plinth area is public access, becomes part of the local park community. All the retail spaces were located here, so we engaged local businesses to have their retail space here, engage local food providers to make sure that people had access to healthy food, made sure it was vegetated to allow for heat stress reduction. And this became kind of a programmatic space for the community in case of a disaster, whether forest fires or earthquakes, etc. And so this kind of access to nature and to biophilic elements is not just for the patients in the building, it's also for the community. So this is an open space for everyone, and we added program space here that the community needed. There was program space for care, for early care, for daycare, for those who were visiting to get care who couldn't afford to have that care at home. And I kind of want to leave you with a broader project that is a triple net zero project for energy, carbon, waste, etc. But really pushes back to a focus on how these systems all work together. This is Hamilton, Washington. It floods every 5 years or so. The flooding causes a lot of pollutants to go into the river to impact salmon populations and orca populations near Seattle. And so they've opted to relocate because of increased precipitation and the fact that the space is no longer livable due to climate change. And so the Hamilton solution, as I mentioned, is triple net zero, as a big focus on everything I just talked about from an energy and carbon standpoint. But the unique thing here is the kind of revitalization of habitat and trying to match the ecological performance of that ecological baseline. So again, when we drop a pin for these projects, we're pulling in data about biodiversity, about water infiltration, water evapotranspiration. And so can we match the same kind of performance on the site as a undeveloped pre-industrial area, pre-agricultural area does? And so, if we don't, we're going to have flooding issues in the future. We're not going to replicate these flows. And so we've actually tried to replicate within this project the same kind of infiltration, evapotranspiration, soil types as a pristine site, right? So that we don't have the issues of flooding in the future, and that we can revitalize biodiversity. And so in lieu of just meeting typical stormwater runoff calculations, right, that we usually do, we have to look at these metrics to truly be regenerative in the future and to avoid these issues. It's also above the 500-year floodplain, which these days is still not safe, right? We should be looking at the 1,000-year floodplain. And so all of these things, the intention is to connect humans back to nature, which we are a part of, and to make sure that our social systems are working in tandem with ecological systems, and to see how they impact each other and how we design for the system and not just the project. So that's just kind of an overview of the framework and some projects. The intention is to do this for all categories of all projects. Some of these projects hit 4 or 5 categories, but I think we can hit all of them eventually. So looking forward to chatting, taking some questions. Thank you.
Awesome. Thank you so much, Colin. Anyone have questions they want to jump in on or put in the chat? The project that you talked about relocating, Colin, how far did they, or the city, how far did they kind of move?
Oh, how far away?
Yeah.
Not very far. It's just about 4 miles. It's just up the road a bit on higher ground, because the community has been there for decades, if not centuries, and they don't want to go too far away. This is still their home. But every 5 years, they're having to relocate a little bit within town or get money from FEMA and insurance, and it's really a drain on their mental health and wellness. And they're trying to stay close.
Daniel, you've got a question in the chat. Do you want to come off mute and just maybe ask that?
Yeah, sorry, I'm not reading chats.
Okay. Oh, can't talk. So he's asking how you make the pitch for community. And I also see that Ralph, your hand is up as well. So we'll go to you next.
How do I make the pitch to focus on community?
I think that's the question. Yes.
Okay, I guess, yeah, it's let me answer this how I think you're asking the question. So the pitch for community is tough sometimes. When we have public projects, it's easy because you have to have public feedback sessions. You have to do community surveys, community engagement, but some of these projects are private. And so the client doesn't always want to engage the community or understand social equity concerns in the community. And so you have to go back to things like their mission statement, right? The second we put up this mission statement from UCSF and we said, hey, this is important to you. If this is important to you and you truly want to meet the Hippocratic Oath and you truly want to design for your community, we need to have more community engagement. And so we planned in community engagement on the project, which didn't have a whole lot of it initially. And this is a large project. It can afford to do a few sessions. It's not always possible to pay for that. And so that's why we built this tool, is that on smaller projects, Lawrence Berkeley, the Welcome Center has a much lower budget than some of their lab buildings. And so for this one, we didn't have as much community engagement. We had to rely on the data to think about the community and try to verify those things with some experts in lieu of having a big engagement. So it varies. But the pitch is always, you're part of the system. This is your mission statement. These are your people. You have to be doing this. Sometimes it works, sometimes it doesn't.
Ralph, you want to jump in?
Yeah, hi, Colin. Thanks for sharing the framework. I guess my question is that a lot of these issues, there's so many, they seem very daunting to try to tackle them all. Have you developed kind of a guidebook for your firm or for sharing with others in terms of how to approach some of these, in terms of the kind of metrics and tools that you use to come up to measure these issues?
Yeah, I think that the best, it is daunting. I've probably presented this 5 times to the same people within the firm who are design principals and are are interested, but it's not part of their DNA to stop drawing and to look at data and think about these things. And it just takes continued education and, again and again and again before they understand. And I think the thing that helps the most is I give them access to this tool. And what it does is it shows them step by step as they walk through it, what data to look at. Then it shows you the metrics, right? So at the end of your input into this tool, it gives you suggested metrics for each category. What it doesn't do is give you suggested strategies, right? So it really then requires you to have work sessions and vision sessions and say, okay, we have to meet this level of indoor air quality or lighting to be regenerative. How do we do that with design solutions? So it's a more intense process. I think I don't have a slide in here, but it's kind of like the McClaney curve that we used to show for BIM, is doing as much work up front as possible is actually going to save you time at the end. So I'm trying to shift a lot of hours into conceptual design and SD, and do this data collection and research before you get to design. And that's tough because we've been pitching that for what, 25 years now, to shift all the sustainability stuff up front. And we still see projects that schedule it like we have been doing for 25 years. So it's always a person-to-person engagement works best, forming those personal connections and inspiring people like that to really have people do this. Don't have to answer your question, but some successes, some failures.
Yeah, thank you very much. Appreciate it.
We've got a question in the chat from Brandon about whether the hospital in California is complete, and if so, how is the community using the space?
Construction documents at the moment.
Not there yet.
Yes.
Okay. We'll have to report back on that later then.
And they take a while. It's going to be 3 years before it's built.
Got it. William, you want to come off mute with your question?
Yeah. So when you're looking at these projects overall to understand the renewable energy requirements for it, are you looking more at the utility consumption, or is it more looking at the amount of carbon offsets to move it into a regenerative category?
Yeah, I guess when we look at this graph, I'm not a big fan of pitching RECs or offsets on projects. I mean, if someone really has to do something for a PR move, that's fine. But this graph that we show and all the calculations we usually do, it's a little squeezed, so apologies. But the yellow is operational carbon, and this was in Pacific Northwest. So at some point, hydropower and renewables are going to be the majority of the grid. So our operational carbon goes down to almost nothing within 10 years because we're connected to a certain utility provider. And then the embodied carbon, orange, becomes the chunk of this, and it increases every 10 years with fit outs and changes. And so all of that carbon on top of the graph right there has to be offset to some extent with renewables. And this is assuming energy efficiency, right? So this is assuming this saving maybe 65–70% of its energy use intensity, whether natural gas or electricity or all electric. But how do we then offset that on site? And so the below line green element is how much renewables on the roof, on the site, et cetera. What we don't have put in here is kind of heat pumping technology, kind of moving away from combustion-based boilers and chillers and going to heat pumps and geo-exchange. This is just a pure initial look at how much space would you need to offset your project with renewables. And so this is purely renewables. I don't put the RECs in here unless someone really wants to have a PR story. No offense to RECs.
Yeah, no. Thank you.
We got a couple more questions in the chat from Frank. How does lighting, color, temperature, and intensity fit into this? Yeah,
you'll see I didn't focus on the human health KPIs as much as I should because of the time frame. But there are a number of human health indicators here that you can flex up or down. They're important to the project. And if I had to argue, how are we regenerating human health? Some of these KPIs are taken from bleeding edge requirements in either LEED, Living Building Challenge, or the WIL Building Standard. And so looking at spatial daylight autonomy, glare control, and then kind of circadian rhythm lighting within the space, or a certain CRI within the space, does play into these indoor environment KPIs right here. So the indoor environment KPI has about 10 different things you have to hit from WIL Building Standard and LEEDs in order to achieve that quote unquote regenerative target, right? Which means you're bleeding edge in the industry. This space is, much healthier than a typical space. So you are to some extent regenerating human health and productivity. That was true for the Orange County Sanitation District. We didn't need circadian lighting for the space. It was all natural lighting because of the layout. But the ability to control color rendering index in some of these interior spaces was considered. So it's a factor in the indoor environmental quality KPI right here. I just didn't go into it in detail.
Great. Let's see. We had another question in the chat from Olivia. How have you promoted changes in embodied carbon that don't necessarily directly impact the building users, especially given the cost bumps of mass timber and others and everything, cost bumps of everything?
Yeah, so I mean, Olivia, the mass timber story is just the most fun story to talk about because of the sequestration and reduction ability. We don't always have the opportunity to specify mass timber, especially given the demand is so much higher now. So we're spending a lot of time with reduction in embodied carbon in concrete. So we're looking at things like fly ash. You can only maximize that to a certain level. Then you get into things like carbon cure, which only provides you about a 5% additional decrease. Recycled aggregate and supplementary cementitious material goes into that factor. And so, we're maxing out at about 40–50% reduction in embodied carbon in our concrete, depending on where it's located and what the plant is doing for their process. There's a few really exciting new manufacturers that are looking for like chemical catalyzation of the cement in lieu of heating everything up in the kiln so much. We haven't seen it installed yet, but we're excited for that. Hemp concrete is also a consideration of ours. So we're always looking at different materials to reduce that. I will argue though, the individual cost of mass timber is a line item. And if you remove that from a project because a single line item costs more, we're doing the calculations wrong, right? And I've seen this a number of times with contractors. If you truly price a building properly with mass timber, it should be less money depending on where you're located. So the building should be lighter, so you have less, your foundations are smaller. The building should allow for less interior finishes. So remove all of those interior finishes from your cost information. You can do prefabrication off-site and bring it to site. We've saved 3 to 6 months in construction time due to mass timber. So that should be a massive savings for projects, right? And so if these things are priced properly, they should go into projects. If they're priced as a line item, that's the wrong thinking, and it's not thinking about these broader, holistic systems. But yeah, we're all over the place on it. So thank you for that question.
Great question. Great to know how much savings there can actually be when you really work the budget the way it should be.
Yeah, and I have a slide with a breakdown of some recent work with line items like that that show you the savings, but I didn't put it in here. My apologies. Depends on where you are too. Like the contractor has to know how to do it properly, right? So regionality is very important. So we brought people in from the Pacific Northwest to consult on projects in the upper Midwest and the East Coast to make sure they're doing it right.
Any other questions? We're a little over time, but if anybody had one more. No. Well, I was just reminded by a question in the chat that we do record all of our coffee breaks and post them on YouTube, and those are available on our YouTube channel. I usually always drop a link in the event page of our website as well, so you can always go back to find those just in case you want to share this with anyone. We do have a couple upcoming events I want to share before we close out here. We have a benchmarking 101 session next week with the City of St. Louis and the Building Energy Exchange. And we have an emerging professional happy hour on June 1st with AIA's JEDI committee, the Justice, Equity, Diversity, and Inclusion Committee. And then our evening program in June will be June 13th, and it's our annual Lead Building Tour. We'll be at the Missouri Foundation for Health. And I'm excited. This is the first tour we've done in person since 2019. So I hope everyone will come. And as an extra incentive, we're raffling off a pair of some Cardinals tickets to those who register by June 6th. So, and I'm going to try to get lead specific continuing education for this one. So that'll be a big bonus. I know how hard it is to come by. All right, well, Colin, thank you so much for your presentation. This was so great. We were bummed that you couldn't make it to the May 9th event, but this is a great alternative, for folks who are as busy as you are. So
Appreciate it. Thank you guys for your questions.
yeah, thanks all. Have a great Friday.
All right, bye guys.